Bismillahirrahmanirrahim. So in this lecture we are going to discuss outer joins. If you remember, in the last lecture we discussed about the inner joins, particularly three types of inner joins: the theta join, the equijoin, and the natural join. Now the theta join was when we could use operators such as less than, equal to, not equal to. The equijoin was particularly for the equality operator, and then the natural join was a special case in which the two tables had the same column name and with similar values, so that you can join on that column without having to specify the column on which the join is to occur. So it's going to assume that it's the column on which we have to join the two tables. So next we are going to look at the outer joins. The inner joins used rows that had perfect matching between both tables. So in both tables you had a value for that row. In the outer joins we are going to look at a type of join where even if you don't have a matching value in another table, it can still be part of the result. So, but before we go into that, a couple of questions that were asked to me. The first one was, what is the difference between the inner join and the natural join? So let me explain that again. If you look at this, we have two tables, table A and table B, and table A has two columns, column 1 and column 2. Similarly, table B has two columns, column 1 and column 3. So you can see that column 1 and column 1 here, they are both the same. So they have the same name. So column 1 here and column 1 here, they have the same name. This is necessary if you want to make a natural join, because that's what's going to make the join on. So for an inner join, we write select asterisk from table A as A. So we are naming this as A. This will become A. And inner join table B as B. So this will become B on column 1. So we are specifying here, because it's an inner join, we have to specify on which column we have to make the join. So we have A dot column 1, then A dot column 2, then B dot column 1 and B dot column 2. So since we use asterisk over here, we see that both these columns as well as these two columns are included in the join, even though this and this are one and the same thing. So in an inner join, this is repeated. In a natural join, you see that the column 1 is included only once, and the reason it happens this way is because the name are similar. No, in fact they are the same, not similar but the same. So the syntax for natural join is select asterisk from table A, natural join table B. So in this case, this part is missing. On which column you have to make the join, this is missing, and the natural join is going to assume that because the names of the two columns are the same in the both tables. So that was the difference between the inner join and the natural join. Now the second question is, why do we need these two things? So here I have listed two options. So in the first option, if I write select asterisk from table A, natural join table 2. Now this is equivalent to saying select asterisk from table 1, inner join table 2, for instance on table 1 dot room number equal to table 2. So assuming that room number is the common attribute between the two tables. So in this option I have just written natural join. So it's going to, since the room number is the same, it's going to make the join on this attribute. And so the question arises, why do I need this option? Why do I need to specify this if it's going to do it naturally anyway? And the reason is that this is a short form, and in this case it's going to be an equality join between the two tables, table 1 and table 2, based on room number. What if I want to make the join a little more complicated? For instance, if I want to write the join has to be on table 1 dot room number equal to table 2 dot room number, or that table 1 dot room number is null and table 2 dot room number is null. So if I want to have any other addition, this syntax does not allow me to do that. So I have to, this is in fact the short syntax and this is the full form. So I need this to be able to make the queries more complicated. On the other hand, if the query is not complicated and the two tables have a column with the same name and it is that column that I want to make the join on, I can then use the shorthand or the natural join form of it. But it's not exactly just a shorthand, it is a special case of the normal inner join. So that was the difference between the natural join and the inner join in terms of how they will display and what's the difference in their syntax. So coming back to today's lecture, it is the outer join. So the type of joins we have is in SQL, we have the inner join, the self join, the cross join or the Cartesian product, and the outer join. So we have done with this part. The outer join itself is divided into three categories. So we have the left outer join, the right outer join, and the full outer join. So we'll look at these three separately. So in general, the outer join includes rows that may not have a matching partner in the other table. And this is in contrast with the inner join, where only those rows which have a common value in both the tables are included. So an outer join does not require each record in the two join tables to have a matching value only. The resulting join table will contain records from one or both tables even if no matching value exists. So this is the key, even if no matching values exist. And we'll see with the help of a few examples how this is done. So the outer join select all the records from one database table and only those records in the second table that have a matching value. So they don't have to be common between. So this is a good representation of how a join looks like. So this is table A and this is table B. These are the values or the attributes that are common between, not the attributes but the values, the rows which are common between the two tables. The inner join corresponded to this part of the diagram. In the outer join, we may also include rows that exist in either this part or this part, depending on whether we are having the left, the right, or the full outer join. So we look at that with the help of a few examples. So consider the left outer join. One thing you must have noted is that this, this left part here, this is a representation of the left outer join. So you simply have something like this, and then you add this to denote that this is the left outer join. So the result of the left outer join A, left outer join B always contain all records, so all records of the left table. So all the records, when I say a left outer join, it means everything in the left table will be there in the result, but for the right table, only those rows that have a matching entries in this table are going to be included. So it is like the inner join plus rows of the left table. So that is the left outer join. So even if the join condition does not find any matching record in the right table, so all the rows of the left table are included. A matched tuple from A is processed normally. So if there is a matching between A and B, then it's considered as a normal data, and that's how it's going to be processed. But since we are saying that all the rows of the left table are going to be included, so some of them may not have a matching value in the right table. How do we deal with that? We append them with null values. So to see how this works, so this is table A. It has two attributes X and Y, and this is table B, which has two attributes Q and V. So now we are going to make a left outer join between these two tables. So it's going to be A, and then I'm going to put the symbol for the left outer join, and I need to specify on which attribute. So this is not a natural join. I need to specify which attributes are going to be the ones that are involved in the join. So let me put it as a dot x equal to b dot u. So this is the condition, and the join is between A and B. So this is table A, this is table B, this is a join, and the join is being done on this these attributes. So what are we going to have as the result? The result of this is going to be, let me put it as this: I have x, I have y, I have u, and I have v. So this, since this is the left outer join, so I'm going to take the left table. So A is on the left part. I'm going to take A. So 1, 7. So I'm going to put 1, 7. Next, I'm going to look. So the matching criteria was on x. So I'm going to look what's the value of x, and the value of x is 1. So it's being matched with u. So I move to u and I search in this. Do I have a 1? Yes, I do. And I put this entry. So 1718. So everything is normal. This is the same as we have been doing before. I move on to the next row, 2. Again, I check 2 exists. Yes. So 2, 5, 2, 3. So this is also. I move on to the next row, 3. Does 3 exist here? And the answer is no, it doesn't exist. However, if you recall, we said all records on the left table are included, even if they do not find any matching record. So all the rows in this table are going to be included. So I'm going to include from the left table, I'm going to include 3 and 4. But what do I do here? Since I don't have a matching entry, what do I do here? These 4 and 9 are not corresponding to this. So I'm just going to write it as null. So this is how the table is going to look like. Excuse me, it's not very easy to draw with this. So that's how it's going to look like. So this is the odd entry that has come as a result of the left outer join, and since there was no corresponding entry, we replaced it with null values. Let's look at another example. So this is a good representation. So this is how it looked like. So these are the entries that are common between the two tables, and this is the entries that are only in the left table but not in the right table. So all of these entries and all of these entries are included. So if we look at this table, the first table, it's about prices. So we have a product and a price. In the second table, we have quantities and we have product and quantity. So oranges and tomatoes. So these two, oranges and tomatoes, they exist in the left table, but they don't have an entry in the right table. So if you look, we have potatoes here, we have potatoes here, we have avocados, we have avocados, we have kiwis and kiwis, onions and onions, melons and melons. So all the entries are there. However, oranges and tomatoes, they don't exist. But since this is the left outer join, it means even if there is no corresponding entry over here, these two must be included. So these are going to be included even if there is no corresponding entry. So the query to do this is select prices dot asterisk. So I'm going to take all the attributes. So asterisk is all the attributes, and from which table? From the prices table. So all the attributes of the prices table, and the quantity from the quantities table. So this attribute here. So select prices dot asterisk quantities dot quantity from prices left outer join quantities. So left outer join all the values in the left table and the common values. Which columns we have to make this join? So from the prices side it's the product, and from the quantity side it's also the product. So product and product. So we have all the entries of potatoes. Here are potatoes. The price is $3. There's a matching entry, yes, so you include the quantity as well. Similarly, for avocados we have $4. There's a matching entry, so 63, this is also included, and so on, until we come to the two entries which occur only on the left table but not in the right table. So for these oranges and tomatoes we have, so oranges $5, we have an entry here, $5, and tomatoes $6, we have a corresponding entry here, but since there is no entry over here, we replace it with null values, and this is the left outer join. So why is it important? I want to combine the two tables, prices and quantities. Basically, I want all the products and their prices. If I have the additional information of quantity, include that as well, otherwise leave it empty. So this is what this table is doing. It's a combination of these two tables, product and prices. In the instances where the quantity is also available, we are going to list it. In those instances where it's not available, we are going to put it as null. So this is the combined table from the left outer join of these two tables. The right join is very similar, but instead of doing it on the left side, we are going to include the instances on the right side. So everything else is the same. So let's look at this example again. So we have A and B. Now I want to form a right outer join. So I'm going to put A and then this right outer join, and again I need to specify on which attributes I'm going to make this join. So this is going to be A dot X and equal to B dot U, and I need to put the name of the two tables. So A right outer join B. So the join is between tables A and B, and the join is being done on the values A dot X equal to B dot U. So let's look at the results. Let me put it again. There's going to be X, Y, U and V. So let's look at the first value. In the previous example, I was considering this row and then searching for the corresponding entry in the right side. In this case, I'm going to, since it's a right outer join, I'm going to take the first row of the right table. I'm going to search for a corresponding entry in the left table. So does one exist? Yes, it does. So I'm going to again write 1, 7, 1, 8. And then move on to the next row and then find a corresponding entry, yes, and then it's going to be 2, 5, 2 and 3. When I move to the third row, now I don't have a corresponding entry here. I can't match with this because X is being matched with U, so U is being matched with X, so U has to be matched with X. I need to find the entry in X and not in Y, so this doesn't count. So since I don't have a matching entry and I'm going to include all that is in the right side, so it means that the left side will be missing. So this means I'm going to have 4, 9 over here, and since there is no matching entry, this is going to be null and null. If you recall, in the left outer join, the entries here or 3 or 4 were included, and these two parts U and V were null. In the right, 4 and 9 is included, and the values for X and Y, these are null. So this is the result of the right outer join between tables A and B. So let's move on to the other example we have. So in this case, again, potatoes, we have the price and we have a corresponding entry. For avocados, we have a corresponding entry. Kiwis, there's a corresponding entry. Onions, we have. Melons, we have. So in this case, we're not bothered with these because this is the right outer join. So we are interested in these values. So broccoli and squash. So neither of them exist over here. So we are going to, make the table as before, but in this case, the price is going to be null since the price of broccoli and squash is not available to us. We know the quantity, but we don't know the price. So this is going to be the right outer join between the two tables, prices and quantities. Next, we are going to move on to what is known as the full outer join. And the full outer join is basically the combination of the left and the right outer join, except that the common values are not repeated, they are only written once. So the result of the full outer join, and this is the symbol for the full outer join, always contain all records of both tables, even if the join condition does not find matching entries. So we are going to include the rows for the left table that do not have a matching entry in the right table, and then we are going to include the rows of the right table that don't have a matching entry in the left table. So basically it's a combination of the left and the right outer join. So let's look at our example and see how this will happen. So I'm going to take the first table A, and I'm going to have the full outer join. So I have this on both sides. I still need to specify what I'm doing, making my join on. So it's going to be A dot X equal to B dot U, and the name of my table. So the join is between A and B. The type of join is a full outer join, and the join is being made between A dot X and B dot U. So let's see what is going to be the result. So again, I have X, Y, and U and V. So in this case, I can take basically any one of the two tables first. So let's take this. I have 1, 7. There's a matching entry, yes. So I'm going to have 1, 8. And then I take the second row. So I took the first one and then take the second one, 2 and 5. So 2 and 5, is there a matching entry? Yes. And then I have 2 and 3. And then I move on to the next row, which is 3 and 4. So I write 3 and 4. Is there a matching entry? No, there is no matching entry. So I'm going to write a null and a null. And now that I'm finished with this, since it's not the left, it's full outer, it means both left and right. So I'm going to move on to here. So this was taken care of, this was taken care of, it's already included in the result. However, this is still missing. So this is still missing, in which case I need to have the right outer join for this. So here I will have 4 and 9, and since there is no corresponding entry over here, so I'm going to have null and null. So this is basically how my full outer join is going to look like. So it has entries that are either in the left table or in the right table. So both of them are included, and they're not repeated. So 1 and 2, this was common. So it's not like simply taking A like this and taking B and then stacking it together. No, that's not the case. There are going to be common rows between them. For instance, these two rows are common, so they are not repeated. They are only included once over here. So this is not just simply stacking A and B. So it's a proper union operation between A and B. or it's the union operation between the left outer join and the right outer join. So technically that's the right way to put it. So let's move on to our other example. So we have oranges and tomatoes and broccoli and squash. So for oranges and tomatoes, we include them in this. We include these rows with the null on this side, and for broccoli and squash, we include the rows here with null on this side. So as you can see that the product is repeated. So prices dot product and quantities dot product. If you don't want them to repeat, you'll have to put that in the select. So that was the full outer join. So it's just a combination of the left outer and the right outer, and the intersection is only repeated once. So those rows that come as a result of either including the rows on the left with no matching values in the right, or the rows on the right with no matching values in the left, or both in case of the full outer join. So this is the left outer join, this is the right outer join, and this is the full outer join. So these rows here, these rows, these are known as the dangling tuples. Dangling tuples mean a tuple is a row. So a dangling tuple is a row with no corresponding entry. And so we have another example over here, and this is a very good example in which you can see the exact difference between all the type of the joins. So in this case, I have 4 users here, and there are 5 entries of what these users like. So like, what's their hobby. So the 2 tables are the user table and the hobby table. So we have the user table and we have the likes table. So 4 entries here and 5 entries here. So the way to interpret it is saying that so ID, so I am ID number 1. It means that I like to play football and I like to play chess, which is right, by the way. So if I put an inner join, if I use an inner join, this is how it's going to look like. So select users, so that's the name of the table, dot name, likes dot like, so this is likes, the name of the table, and dot like, the name of the attribute, from users join likes on user dot id equal to likes dot user id. So this is going to give me an inner join. It means only those rows are going to be included that have a matching value in the other. So for instance, there is no user id 2. So user id 2 was Imran. So user id 2 does not exist here. So you won't find it here either. Otherwise, we have activities for user id 1 and user id 4, and user id 5 does not 5 is cricket, but we don't have a corresponding user here. We don't have the name of the user, so that's not also included in this result. So only those values. So what we have to do is we have to search 1 with 1. So the name Fawad with football, so this occurs here. Again 1 with 1. So we have chess, we put it over here, and then you move on to the second. So we have 2. There is no 2 over here, so that's not going to be included. Then we move on to 3, Sadia, and 3 photography, so that's included over here. And then we search for 4 here, and that's skiing, and that's included over here. So that's the inner join. Contrast this with the outer join, and we have the 3 different kind of the outer joins. So if I'm using the left outer join, in this case we see that Imran here exists in the left table, even though we don't know what he likes, but the entry is still included with a null value. The other entries are the same. For the right outer join, we know that somebody plays cricket, we just don't know who it is. And so and for here Imran does not have an entry, So Imran is not included, but cricket is included. So we have our 4 instances that come as a result of the inner join, and then we have cricket, but we don't know who is playing this cricket. So but it's included. Why? Because we are using the right outer join. This was the right table, the right hand side table, so its values are included. And then we have the full outer join, in which case both Imran and cricket will be included. So we have our normal values, and we have Imran, but we don't know what he likes, and but he's included. So I'm sorry, it's going to be this. So we have the name, but we don't know what he likes, and then we have photography, and we don't know who likes that. So all these are included, and the syntax for this is that you make a left outer join and you make right outer join, and then you form a union between these 2 joins. So that's how it's going to be included. So finally we have what is known as the self join, and self joins are an important concept in databases. One of the reasons that we need a self join is when the data is stored in a single table and we need to create a reference from instances in that table to other instances in the same table. So if you recall, we said that one fact, one table. So ideally, for instance, if I give you an example, let's suppose GIK has to store the information about all its employees, particularly its faculty members. So they're going to go into one single table. Let's call that the employee table. So all the information is stored in this table. Now, as you know that each faculty has a head or a dean of that faculty. So that dean will also have an entry because the dean is also an employee. So he or she will have an entry in the same table. And on top of all the deans, we have the prorector academic, and that prorector academic is also a faculty member. So he or she is again going to have an entry in this table. So to make sense of all this, what we do is, instead of having a new table for dean and a new table for prorector, what we do is we use the same table and we add the manager ID of each employee. So if this person here is an employee, we are going to insert the manager ID of whoever is the manager of or the head of this employee. So if I look at it, the way to interpret it here is that if I have, for instance, employee number 5 and Anam, so the manager of this employee is given by ID number 4. So if I want to find who is the manager of Anam, I just have to look for ID number 4, and that ID number 4 is here. So this person is the manager of this employee. So as you can see that both the employee and the manager are given in the same table. So for that we need to have a self join, which means I am joining this table with itself. So let's continue with this example. We have the employee table. So the data is given in this format. So all the data is there. However, it's not very easy to navigate. So I have decided that I want to show this table and display all the managers by name. Instead of having IDs, I'm just going to have all the managers displayed by name. So I have the employee name and the name of his or her manager in this form. So to do that, we have to use the self join operation. So I'm going to use a self join. So how does a self join work? Basically, I am going to have, as you know, that a join is between two tables. So I am going to create a copy of this employee table and have a join of the first copy with the second copy. So let's say I have two copies. So the first one, let me call it as E1, and the second one, let me call it E2. So E1 is also referring to this table and E2 is also referring to this table. So let's go ahead and write the query including the join that will refer this table and find the name of the managers. So first what I need to do is I am going to write my select command and from. So to make it easier to understand, let me make so employee E1, and I'm going to have another employee E2. So these two tables I have left intentionally some gap between because I have to fill it with some other keywords which we'll see in a minute. So select E1, so E1 dot name, and that name for the first part is employee name, so I'm just going to give it an alias. So E1 dot name as employee name, and then E2 dot name as manager. So from the first table, remember that both tables refer to this same table. So from here I am going to get the name of the employee which will correspond to this part, and from the second I am going to get the name of the manager which will correspond to this part. So select E1 dot name as employee name, E2 dot name as manager. So from the two tables, now I left an international space here because I need to create a join between these two tables. Now I have to create a join that matches, so only those managers that are listed here will be matched. Otherwise I have no way of knowing who this manager is. So for that I need an inner join. So EMP, so E1, and I'm going to perform an inner join on employee 2. So this is an inner join, and for inner join I need to specify on which column I am performing this inner join. So this is going to be E1 dot and manager ID equal to E2 dot and simply ID. So what will happen is that I'm going to, once I run this query, I'm going to take the left table, this one. So for the first row we are going to look at the manager ID here. So when I look at the manager ID I get this, and I'm going to try to match it with the ID of the second table. So I'm going to match this value, I'm going to search in this column. So I'll take the first row from the first table. So this one is from E1 and this searching is done in E2. So the manager ID from the first table is being searched in the second table, and because it's a self join, so both tables are essentially the same table. And once I find this match, so I have a match over here, so this is one and this is one, I'm going to write the name. If you remember, E2 dot name as manager, so I'm going to write it as manager. So I have this first entry over here. So I move on to the next row, this one. So the name is here, E1 dot name, so I'm going to just put the name right here, and then look at the manager ID. So manager ID is 1. Again I'm going to go and search it in this column. So I have another match over here which happens to be the same name, so I have the same manager. For the third row I have the name over here which correspond to this part of the query. So I'm going to put the name right over here, and then I have to perform a match. So e1.manager_id. So e1, I'm in this row, get the manager ID, move on and start searching over here. So once I search over here, I'm trying to find ID number 2. So I find the ID number 2 here, and this value is Muhammad. So I'm going to add Muhammad over here, and so on until I reach the end. I have found all the manager IDs. So this is how the query works. Another way of visualizing this query is if I replicate this employee table into 2, so it is very clear how it is done. So this is the query, it's the same query, and in this case I have shown the 2 tables differently. So this is E1 and this is E2. So E1, so I'm going to get the name. So the names are coming from here, this name, and the manager ID is being searched here. So oops. So the manager name comes, I can circle it, this names come from this part, and for the second one I have this name, it's coming from here, and then I search for the manager ID, get a match over here, and then this is from here. And for the third row, I have the name from the first table, so I get the name over here, look for the manager ID, get a match here, have this name and this. So this is perhaps an easier way to visualize how the self join works. And it's important to remember that this is an inner join, because we don't want to have extra rows of people who either don't have a manager or of managers of which we don't know which are the employees that are working under this manager. For that reason, we are using the inner join and not one of the outer joins that we just saw earlier in this video. So this is why a self join is important, because if we could not make a self join, it means that we would have either added the manager name directly over here or stored the manager information in a separate table, which violates our rule of one fact, one table. So that's why self joins are important. So I hope the join is clear. In the last video we looked at the inner joins, and in this video we looked at the outer join and the self join. So if you have any query, you can either post it in the comments below, or you can email it to me, or you can ask during the interactive session that we'll have on MS Team later in the week. So thank you.